Thanks guys for showing up to this tutorial. We'll be talking about families and how to create your own family. Um, so what is a family? Basically, Revit has, I guess, three tiers of organizing its model elements. So we have family at the top, we have type following under it, and the last is an instance. And so what are in families are major building elements and components. You could see these in your project browser. So if you have your project browser open, there's a section called families. And these are basically all the major groups that we'll be dealing with. And you'll notice that it's mostly based off building elements. So we have stairs, roofs, walls, furniture, doors, etc. So that is our family. And if I were to take a look at furniture, for example, and open that up, we have a type of our family, which is our desk. So basically our type is a variation of the family. And then further down in this list, our types will have their own, actually, no, I messed that up. So we have our furniture as the family, and then these are our types, which are different dimensions of a desk family. And from there, we have our instances, which are the individual copies or individual instance of a type. And to further describe this, I'll draw myself a wall with two different doors, and we'll take a look at what are available for types and instances in terms of properties. So here we have our door. It's single flush, 915 by 2134 millimeters. This is the same type. These two, however, are two different instances. And we'll know that because in our properties panel, we have a set of parameters that are associated to one instance. And here we have our parameters associated to this door instance. So I could change one of these parameters, and it should only affect one of my doors, the ones that's selected. So that's an instance property. Anything that's an instance property is found in the properties panel of whatever object is selected. And then we have our type properties. This is a global change. So if I'm going to change a type property for this door, this one will also be affected because we have the same type. So if I go to my edit type, we'll be brought into our type properties panel. And here we have our own set of parameters that we can adjust. So for example, I could change the height to 3000, and because these are both the same type, they will both have their updates. So again, the three levels of organization in Revit are family at the top. That just determines what the category of our element is. And then we have our type, which are the variations of that family. And then underneath type, we have in each instance of the type. Any questions on that so far? No? All right, so now we'll look into creating our own family. And in order to do that, we'll go to File at the top left. And we have New, and choose the arrow for more selection, and then we'll have Family. And in Revit, there'll be a bunch of templates that we could select from depending on what family we want to create. So generic model pretty much works for anything. You could do an interesting shape and have it modeled into this template, or you could specify exactly what type of family you want. So I could choose a window family, and that's catered towards making a window. You'll have a framework in which is suitable for creating a window family. And there are also some templates here under generic model, which are host-based. So if you know that your family is going to be placed onto another object, say a wall or a roof, then this is the template that you'll want to start off with. For today's example, we'll be using the metric furniture or furniture template. It doesn't really matter if it's metric or imperial, whatever you have available, we'll have that as our starting template. So we're now brought into a new project file, essentially. I'm going to close all inactive views. So here we have my basically Revit work file, which I could create my buildings and architecture, etc. And then we're brought into a new file that's specifically for our family. So just keep that in mind. It might get a little confusing when we start having more tabs open. So try to keep those as organized as possible. In this workspace, you'll notice that we have two reference lines, or reference planes is what they call, defining our center for the left and right and center for our front and back. And when we're creating our geometries in a Revit template, we are using reference planes as our framework or our scaffolding in order to determine the constraints for different dimensions. So in today's example, I have this piece of furniture that I want to kind of replicate. It's by Dan Brune Architecture, and it has pretty nice proportions. You got the bench, a support fin, and then a little box which has some storage to it. So we'll try to emulate this. And if we look at it, it's pretty simple. As I explained, it was 3 major components to it. We got this flat piece here, and then a box volume. So we'll think of it like that when we're creating our furniture in Revit. So as I said, we use reference planes to determine the framework of our massing. So first we gotta do that. We'll go to the Create tab, and center right, we have our reference plane command, or RP for the shortcut. And I'll start drawing roughly what that looks like. We'll keep these center lines, so they determine the centers, and we'll just create roughly planes that create that box. Doesn't really matter how nice it is at the moment. So there, I've created my planes, and we're in floor plan view. So we're looking at it from above. Yep. And now I can add some dimension lines. So I type DI as the shortcut, or you can go to, I think it's, where is it? Annotate, and then you'll have your dimensions section to create your dimension stringers. The first thing we'll do is select the reference planes in one axis, and then we'll also click on the center line. And what this does is it allows us to ensure that the space between here, the center, and the space between this reference line and the center are always remaining equal. And this ensures that your geometry is pretty much symmetrical. So we'll do that in the next axis and press this little button to toggle dimension equality. So once we have that created, we'll do a new dimension line from one end to the other end. And same for our other axis. So essentially, this dimension line will determine our length, and this dimension line will determine our width for this plane. So we're still looking at it as a framework before we're putting the massings on. And so now that we have this dimension line attached to these reference planes, we can make it a parameter. And by making it a parameter, we are able to modify our object, much like we did with our doors. So when I select my door, we have instance parameters, as I mentioned, in the properties panel. So this is affecting only that in one instance. And then we have type parameters, which are affecting all the instances of the same type. So that's important to determine whether we want this parameter to be type or instance, because that will locate where this parameter is on the object. So I have my dimension line selected, and here under label dimension, we can create our parameter. This is our parameter properties panel. There are a few things that I'd like to discuss here. The first one is the parameter type. So there's two options. We have family parameter, which means this dimension parameter will be associated to this family specifically, or we could have it as a shared parameter, meaning it could be used in multiple families. In this case, we want it only for our furniture, so we'll keep it at family parameter. Second item is whether we want it a type or instance. So in this case, I want it as a type, and I'll show what an instance will look like later. And then we have some of the data that we need to include. Because we are creating a parameter from this dimension line, Revit automatically fills these items in, so the discipline and the type. In this case, it's length, and so we don't have to worry about it. We'll name this something like length, easy to remember. And there, we've created our first parameter. We'll do the same thing with our width dimension now. So I've selected my dimension line, which are connected to these two reference extents. I'll click create parameter, and we'll do the same steps. I'll create a name. This one will be width, and it's a type parameter, and we're all good. So once this dimension has been changed, you could input a number, say 2000. And you'll notice that our reference planes are connected to the dimension line and will adjust based off this parameter. So that's how these modifications are applied. Again, I'll select the dimension line and change the dimension here. And then you'll notice that my reference lines connected to these dimensions have been modified. You can similarly go to this button up here called Family Types within the Properties section. And essentially, this will list all of the different parameters that we have available in our family template. And you can adjust those dimensions in this section as well. Apply, and we'll see that it has changed. Okay. So now we have our parameters in our plan view. Most likely we need to look at our elevation view to see what else is available. So in our reference image, we'll need a height. We'll need a height to determine where this seat position is, and also the thickness of this, this material. So again, I'll go to Create tab. We'll go to Reference Planes, or RP for the shortcut, and we'll draw our datum that determines our height for our family. And then one more to determine the thickness. So again, I'm going to type DI, or go to our Annotate panel to grab a dimension line, and I'll dimension these datums. First one is from our ground plane to our bench height, and then the second one will be the thickness. So I'll have these two. I want this dimension to become a parameter so it could be adjusted. So again, I'll go to this icon, make it a parameter. This will be height. Okay. And with this dimension, I don't want it to be modifiable. So we'll keep it as it is. We can change it to a different number by selecting the reference plane first and then selecting that text box for the dimension line. So I'll make it 50. So our framework will remain at 50 and I will select the dimension line and lock it. So that stays in place. So when I adjust my parameter here for the height, make it 500, for example, this will remain at its dimension and lock to the height of this parameter, like that. Like so. Any questions so far?
No, it's perfect.
Okay, great. And now that we've essentially created our framework, let's start adding the actual massings, the actual volumes that we visually see in Revit. So we'll go to our plan view first. And under the Create tab, we have a few options in terms of creating geometries. And in this case, because our furniture is mostly like planar objects, we'll only use the extrusion command. So with the extrusion command, we're creating a 2D profile that we give a thickness to eventually. So I will draw out my my seat portion first. And I've switched to this rectangular tool so I could click one corner and then the other corner. And this is the important part now. Once you've drawn your geometry, you'll notice that these padlocks appear. We want these to be locked to these references, these reference planes, in order for these changes in the dimension length to be applied to our geometry. So I'll take a step back and show you what happens if one of them wasn't locked. So here I have my three sides which are locked to my reference planes. So when I adjust my reference planes, they should as well modify. In this direction, I have not locked my top profile line. So when I adjust this, that did not go how I imagined it. But when I try to adjust the grips for my massing, anything that's constrained will have this error that appears, which is good. It's warning us that we're going to unconstrain our geometry. But because this top grip has, or top line has not been constrained, it's pretty much it's pretty much free to stay in this dimension. So it's not really constraining to our reference plane here. So if that's the case, then you could choose your grip and slide it to that reference plane and then lock it from there. Okay, so now our mass has been constrained in plan. Let's look at it now in an elevation view. So in this case, it's not in the right location at all. It should be within these two reference lines. So I'll do the same as I did previously by dragging the grip to the reference line and then locking them in place. So creating families essentially is a lot of reference planes as our framework and then trying to constrain our massing to the reference planes. So we have this done. Let's now create our support structure here and then the box. So again, I'll do another reference plane in elevation view. And this could be somewhat the same. This could be, let's say 50 millimeter units. We don't want that. We just want one dimension here. And we'll lock that. And then, yes, another reference line or reference plane for our box. And this one, we'll dimension it like that. This one I'll make a instance parameter. So we'll select the dimension and go to create parameter. This one will be our box width. And instead of choosing type, we'll select instance and select OK. Now, when we go back to that family types button or family types panel, you'll know that you have an instance parameter when there's the word default in parenthesis beside it. So this is an instance parameter versus these three are type parameters. Okay. So now let's continue providing the geometries for this bench. So I'll go to create, and in extrusion, I'll make my box. Is this in the right location? Okay, so I'm constraining this line to this reference plane. That's good. To this reference plane, that's fine. And the bottom line, this has not been associated to it properly, so I'll drag it and then now I'll lock this line and we're good. You can drag your grips just to make sure that everything has been constrained. And if this dialog or warning appears, that means it's constrained and it's warning you that you're going to unconstrain it. And then while we're here, let's make our box geometry. Constrain, 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 and this one also appears to not have. So I've dragged it and locked it, everything's good. And we'll look at it in another view in order to make sure that they're constrained within the other axis, which no, they're not. So I'm going to drag this to this extent. I'm in the left view now. So I dragged it to this extent, drag this geometry to this extent and locked it. And this goes the same for this geometry. Drag and lock. Now we could take a look at it in 3D view. See, yeah, pretty much we're on par with what it looks like in the image. Great, let's load it in just to see how it works in our project file. So load it into project. And because I haven't saved it yet, it's just called family one. So we could just go back into our family template. And instead of load into project, we could load and close. And so we can save it now as whatever name that we want to make it. So I'll say yes. And I think I don't have a folder yet, but I'll just name it bench. Save. Now when we load it into our Revit project file, the family is now called bench, or the type is now called bench. And we'll place it in and we'll analyze it. So if you recall, we had one of our parameters as an instance. So it should appear here in our properties panel. And that one was called box width. So here we can change our box width to whatever dimension we'd like, apply. But if I were to have a copy of it, whatever I have modified for this instance will not affect this other instance. I'll type 800. So my box width has now changed, but the other instance has remained the same. And when I head into my type properties, we're looking at the parameters that affect all the instances of the same type. So these are all my bench. And so if I adjust my height to it, say we'll make this really unfriendly at 2 meters, apply, both of our instances of the same type will have this modification applied to it. So these are our type parameters. And let's go ahead and take a look at all the other ones to see that they're working fine. So yep, these work fine. And this works well as well. So we're on the right track. We'll go back into our family template and make some more modifications. So when we looked into our family types, you'll notice that type name here at the top is grayed out and this drop-down box is not available. So what we have created thus far is basically the parent for our family. And now we want to create different variations of it. So we can select new type here, and we'll say this type is based off the dimensions that we have currently. So we could call it, for example, 2000, not 20,000, 2000 millimeters by, oh no, we should do length by height is probably more appropriate. So we'll do 1000 millimeters by 500 millimeters. And so from the name itself, we'll know what type that we're choosing. Okay. And so now we have one type available. We'll create a new type. And we'll say this one is 500 by 500 millimeters. So 500 millimeters by 500 millimeters. So we've created this new type in which we should probably modify its values in here. So my length is 500 and my width is also 500, and we'll apply that. My box width maybe is a bit too big, so we'll make that 200. So now when I toggle through these different options, I'm toggling through the different types that I've made. So we'll make one more just to show difference. We'll say this is 2000 by 2000. Okay, so now I have 3 types available. And I should probably change these values to reflect the name of our type. There we go. And apply, and that's what it should look like. Okay. Again, we'll load into project. So now that we've saved our family, we don't have to close it again. But now we have this new dialog that's opening up. So under overwrite the existing version, we're just bringing any of the updates and changes over to our family. And so those will become editable. But if we choose the second option, we're going to basically overwrite any of the changes that we've made in Revit. So as we've seen, I changed these box widths and also some of the type properties that affect the height and the length and the width. So those will be overridden to their default if I select the second value. Okay, so that's my bench type, but I also have the 500 by 500 millimeters that I created, the 1000 by 500, and then the 2000 by 2000. Then now all of these are selectable and easily retrieved without needing to do so within Revit. And lastly, we're not restricted to just dimensions. So what I showed are dimension parameters thus far. But if we head back to our family types panel, we can create our own new parameter based off a list that we can choose from. So this is familiar. You've seen that we could select whether it's a family dedicated to this family or a shared parameter. We could choose whether it's a type or instance parameter. And now here, initially, these two were grayed out because I had created my parameter from this dimension line. Now we're creating a parameter freely, openly. We're not basing it off this dimension. So I could choose a type. I could choose an area or slope. So there's many different options. And in this case, I'll show you what material will look like. And then we could call this a material property or parameter. Okay. And now that's included here. I want this actually to be an instance parameter. So let's edit this, and instead of type, we'll select instance. And you'll know now that it's an instance parameter because it has default next to it. So we're in our 2000 by 2000 millimeter bench type. So whatever we select as our material option will be placed into this type. So I'll go ahead and show you what that looks like. We'll make it, I don't have many options right now, so we'll make it glass. And now it's a glass material. If we head over to a different type, this needs to be selected, or we could leave it at that, and that's what the material is for this type. Okay. And then again, we'll load into project. This time I'll overwrite the existing version. Right. And now available in our instance properties are this material parameter. Now that we could update within here. So oak flooring, sure. If we look at our shaded, nope. Consistent colors, nope. Realistic. Why isn't you looking like oak floor? Anyway, so that's how you create a parameter that's not based off a dimension. Does anybody have any questions? No? Okay, so if you want, this is basically the end of the tutorial, but I'll go through another type of family just to see how that works. So one of this, oh yeah, I think one of you are here. You asked if we can create a window that could be attached to a slanted wall. So we can create a family for that. So if we go to File, New, and Family, as I had said earlier, that there are some that are hosted families. So we can choose face-based metric generic model. So that allows us to create geometries or voids or openings on top of a face. So I will show you quickly. So we're creating the reference planes to determine the shape of our opening. Then we add dimensions to it so that we can add parameters to it. And I'm making all these equal now so that it's symmetrical to center lines. Then we'll create these dimensions. And when we select our dimensions, we're creating a parameter. This one will be called height. And the second one is width. Oh, I guess I'm just not thinking straight today. This should be width and this should be height, but you get the difference. And then in our create panel, instead of an extrusion, we want to create a subtraction from this wall. So we're creating our opening. Instead, we'll be using void forms, and we have the same sort of commands. In this case, we want to make a void extrusion. Select the rectangle tool and create our profile. Again, we're locking our lines or our profile to the reference planes so that when our parameters are adjusted, our reference planes will adjust, and thus our massing, or in this case, our void, will adjust. Okay, and now we have to go to a 3D view to take a look at this massing and this void. We're going to cut these two. So I'm taking the piece that I want to keep, and then the second pick will be what I want to cut it out of. Did that work? Oh, no, because they're not even intersecting. So make sure your void is intersecting at least. There we go. So now the opening is available. And then we could start adding our framework through extrusions and also like a glass panel. But I just want to show you that this now works as an opening for our slanted wall. So we'll load it into our project file. Now this family is available to place onto a wall. I have one. Oh, no. I have to create a slanted wall. So we could go to our massings tab and in place geometry. We'll just call this slanted wall. I'll create a line that determines our wall base. And this line, I'll make it an object now by selecting create form. And now that it's a surface, we have the option to play around with it. So I'll just make this a little slanted like that. Hit OK. We have our mass surface, but now we have to apply a wall to it. So under massings, we have this wall option that we can apply to this massing surface. When I hit wall, whatever is available, I have generic 200 by default. That'll be the wall that's placed into our massing. I'm going to hide it. So this is just to hide that surface and not have it editable. And hopefully, fingers crossed, with our family, it's now going to be posted onto this slanted wall, flush with the face. Versus if we had a regular window, it would be perpendicular to the floor plane. So I won't run through it just because we don't have too much time now. But essentially, after you've made your opening, you'll want to then go to your family template and start making the reference line that determine the thickness of your frames, and then add the geometry through using the extrusions. And then, of course, you're going to apply some dimension lines to create parameters, and then some of those parameters could include like the frame thickness and how deep the frame goes. So once you've created a family, generic model family that's face-based, and then created your opening, then you could start making the actual window, which can be placed onto your slanted walls. So to the student who asked this question last week, does this help?
Yeah,
No?
thank you so much.
Okay, great. Yeah, any other questions related to this tutorial? Nope. Okay, so I'm assuming y'all are masters at making families now. So essentially the principles are you're making reference planes which constrain your geometry and using dimensions lines to create parameters that you could adjust, whether as an instance or as a type property.